Hello! In this video, we are going to prove the following theorem. Let S be a subset of the real numbers. If S has a smallest element, then this smallest element is unique. In other words, we're trying to prove if S has a smallest element, then this smallest element is the only smallest element of S. Now in this series, we are using a list of 10 axioms for the real number system, and I'll leave that list of axioms in the description below. Now, our definition of smallest element is as follows. Let S be a subset of the real numbers, and B is an element of S. We say B is a smallest element of S if X is greater than or equal to B for all X in S. Now, in our real number system, our definition of the less than or equal to relation is as follows. Suppose A and B are real numbers. We say A is less than or equal to B if B is greater than or equal to A. Now, the other definitions of the greater than relation, the less than relation, and the greater than or equal to relation are also given in the description below, but this is the only one we're going to need to refer to in proving this theorem. Now, we're also going to be using the following preliminary result that we have proven using the greater than or equal to relation and less than or equal to relation. Suppose A and B are real numbers. If A is greater than or equal to B, and A is less than or equal to B, then A is equal to B. Okay, so now let's get into proving this theorem. Now, we're trying to prove if S has a smallest element, then this smallest element is unique. And to prove that, suppose S has a smallest element. From here, we want to show that this smallest element is unique. And to prove that, what we can do is we can give ourselves two arbitrary smallest elements of S. And from there, we want to show that they are equal. So let's give ourselves two arbitrary smallest elements of S. I'll call them B1 and B2. From here, we want to show that B1 is equal to B2. Now, by definition of a smallest element, since B1 is a smallest element of S, this means that X is greater than or equal to B1 for all X in S. Since B2 is a smallest element of S, this means that X is greater than or equal to B2 for all X in S. So now, since this statement works for every element of S, then in particular it must work for B2. So taking X to be B2, we have B2 is greater than or equal to B1. And also, since this statement works for every element of S, then in particular it must work for B1. So taking X to be B1, we have B1 is greater than or equal to B2. And then applying the definition of less than or equal to, since B2 is greater than or equal to B1, we have B1 is less than or equal to B2. And then, since B1 is greater than or equal to B2, and B1 is less than or equal to B2, well then by star, we have that B1 is equal to B2. And so, putting this all together, we have shown if we consider any two arbitrary smallest elements of S, they must be equal. And that proves that the smallest element that S has is the only smallest element. And so this completes the proof. And so yeah, that's pretty much it for this video.